Well, hello there. Welcome back to Algebra 1B. Today we're looking at problem set 103. We're going to talk a little more about rational equations. Now, that term rational, you need to think fractions. So we're going to be dealing with more equations that have fractions in them. If you look at the first example, there on the left with y over 2 minus 1/4 equals y over 6. These problems we have been dealing with for a while. And whenever we work these problems, the easiest thing to do is to eliminate the fractions. And if you recall, the way we do that is we look at the denominators, 2, 4, and 6, and I look at those numbers and I try to see what would a common multiple be between 2, 4, and 6. Another way to think about it is what would the common denominator be? In this case, it would be 12. So I'm going to use that number 12. And I'm not actually going to turn these into 12s, but I'm going to use that number and I'm going to multiply both sides of the equation, which ends up, I multiply every term by 12. And what that does, that allows me to cancel the fractions and makes the problem easier. So when I multiply by 12, 2 goes into 12 6 times. So I have 6y minus 4 goes into 12 3 times. 1 times 3 is 3 equals, on the right side, 6 goes into 12 2 times, and I have 2 times y. Now I have a much easier problem to solve. I simply rearrange, get y by itself. So what I would do is subtract 6y, leaves negative 3 equals negative 4y. And then one last step to get y by itself, I divide by negative 4. One thing to watch on these is be very careful with your negative signs. And I have negative 3 divided by negative 4. The negatives cancel, and I end up with the answer positive 3/4. So there's y. Now, with today's stuff, our problems, as you can see, look a little bit different. We're going to start seeing variables in the denominator of the fraction. The basic process is going to be exactly the same. We're going to multiply through by a common denominator, cancel the fractions, solve for the variable p. Okay? The thing we got to watch is at the very end we'll have one additional step to do, and we have to make sure that whatever answer we come up with for our variable, we have to make sure that if I were to plug that back in the denominator, I cannot end up with a 0 on the bottom of the fraction. So we'll need to check our answer, plugging it into the denominators, and make sure we don't get a 0, because division by 0 is undefined. So let's go through the steps here to solve this middle problem. Very first thing, I see subtraction within a fraction. What are we supposed to do with that? Anytime there's addition or subtraction within a fraction, we need to group that in parentheses. It's very important that that stays locked together in parentheses. Okay, now we look at our denominators. I have p, 5p, and 5. I want a common multiple, or what would the common denominator be? In this case, it's 5p. So I'm going to go in and I'm going to multiply every term, both sides of the equation, by 5p. Doing that allows me to cancel the fractions. So on the first one, this p cancels. So I have 5 times p minus 4 equals. Second fraction, 5p cancels out completely, which is good, leaves me 16. Minus 5 goes into 5p 5 times, cancels the 5, and I have 1 times p, which is p. Now it's real important that this p minus 4 back here, I forgot to mention, that stays in parentheses and we wait to distribute until we write it all out. Now that I have it written as one big equation, no more fractions, I can distribute. So I have 5p minus 20 equals 16 minus p. Now we need to get our like terms together. I'm going to add p to both sides. So I have 6p minus 20 equals 16. Next, add 20. So 6p equals 36. One last step, divide by 6. And p equals 6. Okay, hopefully not too bad. Now remember, the one last thing that we need to do on these problems is we need to go right back up here to this original problem, and I need to check that answer 6, and make sure if I plug in a 6 down here for p, plug in a 6 here, I need to make sure that I do not get a 0 in the bottom of the fraction. So in this first fraction, if I plug in a 6, that's obviously not 0, so that's good there. On the second part, I have 5 times 6. That's not going to equal 0 either. So I know this answer is an acceptable answer. Sometimes an answer that you'll end up with causes one of those to end up as 0, and if that happens, we have to throw that answer out. Sometimes that means there's just no solution to the problem. Okay? Let's look at this last one. First thing, I have some subtraction within a fraction. So let's group that in parentheses. So y minus 3 is in parentheses. Now again, excuse me, I look for a common denominator. I have this y minus 3. I also have a y. For my common denominator, I need both. So I'm going to multiply by y times y minus 3. Do that to all parts of the equation. Even this side over here, y and y minus 3. Okay, so multiply through by that common multiple of the denominator, or the common denominator. All right, when I multiply the first fraction, the y's cancel. That leaves me 8 times y minus 3. Wait to distribute. You're probably sick of hearing me say that. I'm sick of saying it, but I have to do it. Okay? Second fraction, y minus 3 cancels out completely. Leaves me 5y equals. Now over here, I have 0 times y minus 3. Well, nice thing about 0, anytime you multiply by 0, you get 0. So that helps us out on that side. Now we have an easier equation to solve for y. I can finally distribute that 8, and I have 8y minus 24 plus 5y equals 0. Next, combine like terms. These y terms are on the same side of the equal sign, so I just add them together. That's 13y minus 24 equals 0. We're almost there. Add 24 to both sides. We get 13y equals 24. Last step, divide by 13. And I have y equals. Can you reduce 24 over 13? Anytime you have a fraction left, always check to see if it will reduce. 24 and 13 do not reduce, so that is our answer. Okay, now what was the last thing we needed to do on these problems? We need to check that answer by plugging it back in and make sure we do not get a 0 in the bottom of the fraction. So clear this stuff off. So whenever you look at this, what values of y would make this equal 0? Well, over here, the only way that y can be 0 is if I get 0. So I know y cannot equal 0. I didn't get a 0 down here, so I'm in good shape there. What value of y would make this thing equal 0? Well, 3 minus 3 would be 0, so I know y cannot be 3, positive 3. Well, 24 over 13 is obviously not 3, so since 24 over 13 is not 0 and it's not 3, I know if I plug that into either fraction, I'm not going to have a 0 in the denominator. So this answer is also good. Okay? So, rational equations. We have fractions, everybody's favorite. But we're going to eliminate the fractions by multiplying through by the common denominator. It's okay that we have variables to deal with. We just got to be careful. We multiply through by that common denominator, cancel the fractions, and then we have an easier problem to solve. And again, on these problems, you need to check your answer to make sure you do not get a 0 in the denominator. Okay? That's all I got. I don't know what I'm doing. I don't know how to stop.